Hi everyone, welcome back. Let's see another variation of FCFS algorithm with example. Guys, FCFS mode will be non-preemptive and criteria will be arrival times. And here we have given extra parameter, that is context switching time. In general, context switching time means the time taken to switch from one process to another process. We call it as context switching time. Here they have given it as 2 units, which means that when I am trying to switch from process 1 to process 2, I have to consider this context switching also, right? Let's see. If we take this as a CPU, initially at 0 nanoseconds, let me check what are the processors available, right? So process 1 is available at 0 nanoseconds, so I will take the process 1 into the CPU. And as it is non-preemptive, I will complete my task, then I will exit. P1 completed for 4 units of time and exit by 4 units of time. And now, by the completion of 4 units, what are the processors available for us? P2 and P3. P2 and P3, right? Can we go directly to the P2? No, because as I am trying to shift from P1 to P2, you have to allocate switching time. This is what switching time, right? Switching time will be 2 units, so it will be completed by 6 units. Then P2 will be allocated for how many units? 5 units of time. So 6 plus 5, 11. By the time of 11, 3 and 4 the processors are available in the system, right? So, but as I am trying to use FCFS algorithm, which one will give the priority? Priority will be given to P3 because its arrival time is 4. But before that, as I am trying to switch from P2 to P3, I have to allocate context switch again. So 2 units, that is 11 plus 2, 13. By the time of 13, this P5 also included. Out of this P3, P4 and P5, which one having the arrived at the first? So P3, so it will be allocated. P3 allocated with 6 units of time and done by 90. Now, next it has given chance to P4. But before giving chance to P4, I have to apply context switching time. That will be 21, then P4. Again, it will be done by 29. Am I right? Yes. Because its burst time will be 8 units. Right. Next, if I want to move to one more P5 process, I have to apply context switching time. That will be 31. Then I will apply 2 units for burst time. So P5, 2 units for burst time. That will be 33 units. Now, what they are asking? One is schedule length, throughput, CPU utilization, and overhead on the CPU. Schedule length means maximum completion time of all processes minus minimum time of arrival times of all processes, right? But the maximum completion time of all processes 33 minus minimum arrival time will be 0, which is equal to 33. So L value is 33. And what is the throughput then? Throughput is number of processes 5 by L, that is 33. 5 by 33 is the throughput. Right? What is CPU utilization? So total CPU is allocated for you is 33 units. Out of these 33 units, how much time have you efficiently utilized? If you observe, the time taken to switch from process P1 to P2 is wasted. Right? P2 to P3 is wasted. P3 to P4 wasted. P4 to P5 is wasted. So each and every time 2 units wasted. So total how many wasted is 4. 4 into 2, 8. So if you remove the 8, that will be 25 by 33 into 100% is the CPU utilization. What is inefficiency then? 8 by 33 into 100% is the inefficiency of CPU utilization. Guys, you might get certain doubt, sir, while taking the process P1 into consideration, can we take the context switching or not? Yes, that will depends on the given question, right? So they will say clearly at 0th time, don't consider context switch. Like that they will clearly mention. No need to worry. If they have not mentioned, just go with adding the process, and then after switching from process to process you have to consider, right? As at the 0th time you are not switching from process, right? We are just adding the process, that's it, right? So that's why in this particular question I have not taken context switching at the 0 seconds. Hope you understood this video clearly. Thank you.